This week's lab is called Ideal Gas Law, Molecular Weight of a Vapor. The purpose of this lab is to determine the molar mass or molecular weight of a volatile liquid. And volatile just means that these liquids readily evaporate at room temperature, so it doesn't take a high temperature to evaporate these. They just really easily evaporate. So the ideal gas law is shown here, PV equals nRT. So P corresponds to the pressure, V is the volume, N is the number of moles of the sample, R is the ideal gas constant, which is always going to be that number right there, 0.08206, and T is the temperature. It's important to note the units of all of these variables. So pressure is in atmospheres, which you'll see noted as ATM most of the time. V, the volume, always needs to be in liters for this equation. And then the number of moles is just going to be a number. And then the temperature always needs to be in kelvins. And the reason for these units is if you look at the ideal gas constant, the units for that are liters times atmospheres divided by moles times Kelvin. So those units always have to be in those forms because otherwise the equation isn't going to work. So no matter what units we give in the video, you need to convert them to these units: atmospheres, liters, and kelvins. So the basis of this experiment is called Avogadro's hypothesis, and what that basically says is that any gas that you have is going to have the same number of molecules in a given volume. So you can have 3 different kinds of gas at the same volume, they're going to have the same number of moles. So it doesn't matter what kind of gas you have, but there's going to be the same number of moles in a given volume. So we're going to first find out the number of moles of a substance when we are turning it into the gaseous state. So you can rearrange the ideal gas law to find the number of moles. So here you can see N equals PV over RT. So that is just the pressure times the volume divided by the ideal gas constant times the temperature. So you can easily kind of measure the pressure, which is just going to be kind of the pressure in the room. And then volume is going to be the volume of the entire flask. And then you have the ideal gas constant. And then the temperature is going to be the temperature when the sample has fully vaporized. Then we can determine the mass of the sample. To do that, you just subtract the mass of the empty setup from the mass of the setup plus your sample. And then we can calculate the molar mass, which, if you remember, is grams divided by moles. So that is just mass divided by moles. And we can figure out the molar mass of our sample. So the procedure is pretty straightforward. All we're doing is preparing first a hot water bath, and then we're going to get an Erlenmeyer flask and some aluminum foil to serve as our kind of cap for this. And then we're going to add a certain amount of our unknown to our flask and weigh that, and then you can see in the video that it's dyed a little with some iodine, and that's just so we can see when it has fully vaporized, because iodine is kind of like a brownish tint, so otherwise these liquids would be clear, so it would be hard to kind of tell when they've evaporated. So we've added some iodine so we can see it. Then we will put that flask in the hot bath and vaporize the liquid. So it's just going to the vapor is going to fill the flask. And then once that has happened, we'll record the temperature and then put the flask into an ice bath. And so what that's going to do is take all the vapor and condense it back into liquid. and then we will weigh the flask again, and we'll get the mass of our vapor. So we'll record the pressure of the room, the temperature of the water bath when it vaporized, and the volume of the entire flask. So here is an example problem of what you'll be calculating for your sample. So let's say our sample weighed 1.862 grams, the volume was 345 milliliters, and the temperature was 67 degrees Celsius, and the pressure was 0.9929 atmospheres. So let's find the molar mass. So we've rearranged our ideal gas equation, and we can put the pressure in there times the volume. Note that the volume is now in liters. Then we have our ideal gas constant, and then we can multiply by the temperature. Remember, the temperature needs to be in Kelvin. And then just solving that problem, we end up with 0.0123 moles. So that's how many moles of gas we have in our flask. Next, to find the molar mass, remember that it is mass divided by moles. So we can take our 1.862 grams, divide it by our number of moles, and now we have our molar mass, which is 151 grams per mole. So that's how you do the calculations for this lab.